So welcome everyone. My name is Andy Trice. I am an evangelist for Adobe, and today I want to talk about designing and architecting PhoneGap and the mobile web. Now, how many people are currently building PhoneGap applications? Number of hands, about a third of people. How many people have no idea what PhoneGap is? Okay, a couple hands. Well, hopefully by the end of this, you'll be really excited about PhoneGap. You'll know exactly what it is, and you'll be like, I know what I'm going to do. I know how I'm going to build it, so let's go build some apps and make awesome stuff. Everyone after this, you're like, no, I'm not going to inspire you to make awesome stuff. I'm just going to tell you, like, this is what I would do if I were building stuff. I'm not going to come up with ideas for you. So let's start out with what is PhoneGap. It's basically a technology that allows you to build natively installed mobile applications with HTML, CSS, and JavaScript. Now, when I talk about natively installed applications, I mean apps that will run on your phone or on your tablet, whether it's Android, whether it's iOS. They leverage the ubiquity of HTML and JavaScript to be essentially the UI rendering layer. So, if this is my device, everything inside of here, this is a web view, everything inside of here is the interface of my application. So that includes if you're trying to render content, if you're trying to add navigation, if you're trying to have, whatever visible elements of your application that the user is going to interact with, it's all going to be inside of that web view. The second part of PhoneGap is that it gives you the ability to interact with code on the native operating system layer through a JavaScript API. So if you download PhoneGap today, it'll allow you to access sensors, so you've got your accelerometer, your GPS, your geolocation. You can search contacts on a device. You can read and write the local file system. You can, you can access the camera, so you can take pictures. You can record video. You can record audio. You can have better notifications than a simple JavaScript alert. And you can do all this without having to write a single line of native code. However, if you want to do more than this, so more than PhoneGap gives you out of the box, it also has an extensible API. So with the extensible API, you can create what are called native plugins. Native plugin is a native library, so you write the native part, and then you create a JavaScript interface, and so that your full application, written in HTML, CSS, and JavaScript, can then interact with the native code to tie into whatever native functionality you might want. This could be like a Bluetooth communication layer. It could be something like I want to be able to handle communication with a piece of hardware. It could be tying into, encryption libraries. It could be, basically integration with any API from whatever native code for whichever platform that you're targeting. The third part of PhoneGap is it gives you the ability to take all this code, your HTML, your CSS, your JavaScript, package it up into a single deployable file that can then be uploaded to standard device ecosystems. So for iOS, you're going to hit the iOS app Store. For Android, it's going to be Android Market or Amazon Market or Barnes & Noble Market. For BlackBerry, it's BlackBerry App World. For Windows Phone, it's Windows Phone Marketplace, and so forth. And basically, all you can have one code base written in HTML, CSS, and JavaScript that is ubiquitous and can be deployed across all these different platforms. Do I have a slide? No, I took the slide out where I list all the platforms that you can target. But I know that it's iOS, Android, BlackBerry, Windows Phone, Firefox OS, Symbian, HP WebOS, Tizen. There's a port being worked on for Ubuntu Mobile. So you can create an app that's targeting mobile devices on all of these different platforms with a singular code base. Now, before we get too much into the architecture, it's really important to understand what is a PhoneGap application. How is it when we compare it to native or we compare it to a pure web application? So let's start with the native side. With a native application, you're writing it in the language for whichever platform that you're targeting. So for iOS, we're talking about Objective-C. For Android, we're talking about Java. For Windows Phone, you're talking about .NET, so C#. And it's going to have direct access to the latest API features that are exposed in the operating system. It's going to have the absolute fastest runtime support. However, I said runtime support, I mean runtime execution. However, if you want to target multiple platforms, you need a separate code base for every platform that you want to target. And you have to have, with a separate code base, you have to have developer skills for all of those different code bases. You have source code repository, bug tracking system, essentially architectural patterns and documentation for every one of those platforms that you want to support. But like I said, you're going to get the fastest runtime performance from a native application. It's just not ubiquitous. Now, we jump all the way over to the opposite end of the spectrum. We're talking about a web application. And by the way, the architectural patterns that I'm talking about here, I'm really focusing on PhoneGap when I'm talking about it, but a lot of the development patterns also will apply to mobile web applications. But I digress. So when we're talking about a mobile web application, we're talking about an app that resides in the browser on a mobile device. Now, it's leverages ubiquity of HTML so that it runs everywhere. If there's a single person in this room who has a device that cannot run HTML on it, then I'll be extremely surprised. Anybody can't run HTML? I didn't think so. So it can be accessed everywhere. However, it's really limited in what it can do because it runs inside the browser sandbox. So you can't access local file system. You can't access the media API. So you can't record video. You can't record audio. You can't do a lot of that. But like I said, you can access it everywhere. PhoneGap falls in the hybrid application category, where it takes advantage of the ubiquity of HTML, but also gives you access to native operating system functionality. So you can do more than the browser sandbox would allow you to do if you were targeting just a web application. And that is the access to the operating system, access to APIs, and also that it can run as an installed app that gets deployed through different ecosystems. So it gives you the monetization strategy that, if you're selling your app through different app stores. So when we're talking about architecture for PhoneGap applications, there's a couple things I want to make sure you keep in mind when you're actually designing and you're building these. And the number one is develop for the user. Now, when I mean develop for the user, I mean think about the user experience. What is the user going to go through when they use your application? Is it going to feel like just a really not great implementation that feels like a web page that it doesn't behave like an app, it doesn't have navigational cues like an app? Or is it going to be something that feels native to the operating system that you're targeting, and is it going to have an overall good experience? PhoneGap applications sometimes get beat up as far as the reputation because a lot of times people often treat it as though they're developing a web page and not that they're developing an application. And so I just like to encourage people to just keep that in the back of their mind that you're building an app, you're building it for a purpose and whatever, and you have to understand what the user is going to go through as you're building this. So the second thing when you're building PhoneGap applications that I think you should keep in mind is to develop for maintenance, maintainability, and reuse. So you don't want to have blocks of the same code repeated all over the place. You don't want to have what I call spaghetti code, which is referencing things here and there, and there's no structure, there's no organization, there's no discrete coding patterns, because that's not easily maintainable. If you're trying to get something put together really fast and it's like a quick hit and you just want to get it out the door, yeah, you can do that. But if you're trying to build something that's going to have a life ahead of it and it's going to be maintained, you really have to think about structure up front as you're also thinking about, what's it going to do? How's the user going to experience it? What's the impact going to be on me over the long term? So with what I'll call the old school mentality, old school web architecture mentality, there's the discrete client and server if you have a device, or let's just think of it as either a device or a web browser on desktop, where the client makes a request to the server does some processing, it accesses data from the database, it puts it all together, it sends a response back to the client, it gets rendered. That's great if you're going for a pure web implementation because it's the structure that we're all accustomed to. That's the way that web pages work. But when you're building PhoneGap applications, this kind of an approach, it doesn't necessarily work well. For a couple of reasons. One, and kind of like a primary motivating factor of this is that people often think that I have a website. I can just easily port that into a PhoneGap app. Now I immediately have a website that I didn't, or excuse me, I have an app that I didn't really have to do any additional work. I just wrap my website, put it on there, and it all just worked. But the truth of the matter is that things don't work that way. You can't take something that's server-generated code and just expect it to work on a mobile device and having it completely self-contained on the mobile device. Because when you're making that request to the server, it's not like you're just saying, oh, I'm requesting a file from the file system. It's making a request to the server, and a lot of times the server architecture looks like something like this. Anybody experienced something like that before?
Every day.
Yeah, it's pretty common. You know, you make a request to the server, that goes out to whatever kind of delegation layer, that might go to a database. We have all kinds of complex relationships. We're going to aggregate it, we're going to push it. You can't just put that into a PhoneGap wrapper. Because, well, number one, if you do and you try to deploy to Apple and all the logic still exists on a server and it's basically just a headless web view making a request to a server, Apple is going to reject you. There is no doubt about that. If you have something that feels like a web page, you can pinch and zoom, and you know, you don't have navigational components that look like buttons. If it's just underlined text and it looks like a web page, Apple will reject you. If your app does not work offline, your users will hate you. Apple will reject you. So this architecture does not work well for pure PhoneGap applications. For mobile web, it's a little bit different story, like I said, because you're working in a web browser. People expect it to behave like a web browser. But if you're actually building an app, people expect it to behave like an app. And to build this kind of an application, you employ the single-page architecture pattern. So, by show of hands, anyone not familiar at all with what I'm talking about when I'm talking about a single-page architecture? Okay. Everyone seems to know what that is, so that's good. But basically, to cover in brief so that you guys know where I'm coming from with this. But basically, it's that your application is built on one HTML file. That HTML file is loaded into memory in the web view, and it's never unloaded. Everything as part of that is completely dynamic. So, you know, your starting page literally might look like something like this, where we have HTML tags, we've got an empty body, and we're including one script. And that script could, through other libraries, be pulling in everything else you need to comprise the logic of your application. So the entire UI is created in JavaScript programmatically, and you add and remove from the HTML DOM as necessary. So we're not putting stuff on the DOM right away, we're just putting, like, if we need to create elements, we need to create a UI, we put it on there when we need it, we get rid of it when we're done, and, you know, we do everything we can to get rid of event handlers when it's done so we can release it from memory. So the advantages and disadvantages of this is you know, a multi-page architecture where you're requesting pages from the server, and single-page architecture where you're generating on the UI. First of all, UI generation tier, I mentioned already. With a multi-page architecture, you're generating the UI actually on the server side. And so this increases the size of the payloads when you're going back and forth to the server. For a single-page architecture, you're doing it on the client, so it's, you know, you request it. If you need to access data from the server, you're just getting data. You're not getting all the structure of the user interface. The languages that might be used for this, if you're doing a multi-page architecture, you're going to have obviously HTML and JavaScript on the front end. On the back end, you can have Java, .NET, PHP, Ruby on Rails, Python. I don't know. It could be JavaScript if you're doing Node.js. But on the single-page architecture, the language that you're primarily using when for your client-side application is going to be JavaScript. You're going to generate everything in a single language. You could be requesting data from a server, and that could be something else, but your actual language for creating the UI is JavaScript. For offline support, I mentioned this already, multi-page architecture, yeah, there's HTML5 cache, but you're going to have limited offline ability with that. With a single-page architecture, because you're loading it up front, and with PhoneGap, you're loading it off of the local file system, you're always going to have at least index.html, so you can have it fail gracefully if it's offline, and send a message to the user and just saying, hey, we're offline, get on the network before I'm going to actually let you do anything. Page transitions. So if you're going from one view to another, this might be, you know, we have a new set of data, or we have a new set of images, or whatever, I don't know, whatever you're doing to get from one piece of content to another. In a multi-page architecture, you're relying on the browser. So when you make the request to the server, it's going to take the time of sending the request, server processing data, the latency of sending it back over the wire, and then the browser is going to drop everything in the current view. You're going to have a white flash, and then it's going to render the next page. Page transitions with the single page app, you can make it very, very nice. You can have little loading indicators while data is being loaded. You can have content slide in from the left to the right, or right to left, however you want to build it. And it's going to feel much more like what I'll just refer to simply as an app feel. It's not going to feel like, oh, we have a stateless interface from page to page. It's like, it's an application, it holds state, it interacts nicely, and it gives the user a better user experience. Performance, when we're talking about multi-page architecture, for the same reasons I was just talking about for offline support, page transitions, and you have the latency, round-trip latency, they feel really slow. Where a single-page architecture, when it's architected properly, can feel really fast. Like, it's very difficult to differentiate a high-performing hybrid application from a native application. So the first thing I'm going to talk about for architectural patterns when you're building these is templating languages. Is anybody already using templating in their current applications? Okay, good number of hands. If you guys are using Backbone.js or AngularJS, probably already familiar with this to some extent. But a couple libraries you can use for templates. There's mustache.js, underscore.js, handlebars.js. And what they allow you to do is have an abstraction of your HTML generation from your application logic written in JavaScript. So it allows you to write something like this, which looks a lot like HTML. And from that, you pass in some data. So we have, I don't know if you guys see that all in the back, so I'm using it. So first of all, we have our template, which in this case, this looks like an unordered list in HTML. But you can see that we have some markup around a user's object. And inside of that, we have nested, we've got list items, and we've got some weird brackets around an ID and a name. And then, we close the users, we close the list. Then we've also got a piece of data. This is an array, which contains objects which have an ID and a name reference. And the way that this works is that using a templating library, we can pass this data into that template string, and for each, in this case, for each user, because we've got the users array here, it's going to loop over the array. It's going, for each one, it's going to create a list item, and it's going to inject the ID and the name into each one of those. So that when we combine those to the templating library, it gives us a nice HTML string. And this really lends itself well to abstracting the HTML creation from the actual pieces of data. And this will get into a topic I'm going to talk about a little bit further, which is it lends itself to better separation of concerns. So you're separating like logic from the actual page structure from the actual data of your application. So that leads me next into, actually before I jump over that, let me give you an example of what I'm talking about when we're talking about HTML templating. I've got a user interface here. This is I'm showing it in the browser, so let me actually scale it down so it will look like it on a mobile. We've got, on this side right here, we've got a discrete header, we've got a discrete footer, we've got content in the middle that can be scrolled. And I said the code for this is actually available on my GitHub, I can share it later. This is actually for an article that I'm putting together, or have put together for D-Zone. But basically, for each one of these, it's just a template that gets repeated for each piece of data. Let me go ahead and jump over to the code and kind of give you an idea of what it is. So when the page first loads, I've got right here a body which has a div for content, a div for a header, and a div for a footer. You can see that there's no actual structure inside the content, but that's where all those cards are living. Now let's scroll down just a little bit, and we look right here. And inside of this script block, I've actually got text, which this is my template that's going to be used to generate the actual HTML page structure for each one of those cards. Now, in here, I've got a div. I've given it a class as card. And then in here, and I'm using the syntax from the mustache.js templating library. Each templating library has a slightly different syntax. Like underscore JS is a lot like JSP. The mustache, it puts double or angle brackets around everything that you want to be injected into the HTML string. And there's other ones when I say handlebars.js. I think knockout.js does something. Like there's a lot of different options for templating. But basically, based upon the syntax, I'm going to conditionally put in this div, or I'm going to inject this title, or I'm going to inject this message. And so what I'm going to do is loop over an array, a collection of data, and for each element in that array, I'm going to generate an actual HTML string that's created from this declarative syntax. So that's actually defining the structure of each object. And then I've got some script. And in the script here, I've got my array, which is cards data. And for each item in the array, I've got like a title, I've got message. Some of them have an image, some of them have a banner. And you'll notice here, because some of them have images, some of them have a new banner. That's all related to the data that's in the array. But when I want to actually go ahead and create this interface, we can see here, the other thing about this example is that when I change the width, it's actually programmatically calculating how many columns there are going to be, and it's generating the HTML accordingly to address this number of columns. So this is more of an adaptive UI instead of responsive UI, but anyway. If we go ahead and look at the actual code, the first thing I want to show you is that when the page loads, I am right here creating a compiled card template. And what that's doing is it's grabbing the inner HTML from that script block, which actually defines my template. It's using mustache.js's compile function to actually compile that essentially marked up text into a function that can then be executed on data, and that function will return the fully generated HTML string. So that happens when the page loads. And then I'm actually calling the layout columns function, which also gets called when the page is resized. And in the layout columns function, oops, let me scroll here. And in the layout columns function, it's calculating how many columns should there be, and then for each column, we're creating different divs, which is actually going to represent the structure of each column. But then we're looping over all the data here. So over cards data, for each item in that cards data array, we're going to create an HTML string, which is used by taking that compiled template, passing in the current data item, and like I said, that's going to generate the HTML string, and then we're going to put that in the appropriate column. Now, this example, I don't have a lot of interactivity added in here, but what I really wanted to show was the principle of templating, where it abstracts the creation of HTML strings from different behavioral logic inside of your application. So, with that, let me go ahead and jump on to code structure. Now, there's a lot of different frameworks that are out there. A lot of them use some form of MVX. Because there's model view controller, MVC, there's MVVM, which is model view model. There's like different homegrown versions of that. But in essence, what a lot of programming frameworks use is an abstraction that's some sort of derivative of model view controller. Now, model view controller patterns allow you to have a separation of concerns. So when I talk about model, I'm talking about our data model. This might be data that's generated in the application. It might be data that's being retrieved from a server. But essentially, within PhoneGap applications, we're talking about the model is a series of essentially JSON objects. And then you'll do whatever you want to do with this model. You have the view, which is your actual HTML user interface. So even if you're generating that HTML UI programmatically, or if you have static HTML files, and you're adding interactivity some other way, the view is the HTML, and it's actually two parts of the HTML and the CSS, because the HTML is the declarative structure, but the CSS actually defines how that structure gets presented in the browser. And then we have the controller, and the controller is the logic which defines the behaviors within your application. So this might be click behaviors, it might be managing data, it might be requesting data from the server, it might be anything from analyzing business workflow to processes, or if you're doing some kind of real-time data feed, it might involve the aggregation and capture of data in that real-time fashion. A lot of times people use like kind of homegrown frameworks for this, which employ the same models, but also people often choose a framework. And now with frameworks, we already had a conversation earlier, who's using AngularJS, who's using Backbone.js, but there's a lot of different coding frameworks that you can use, and they fall into a couple different categories. There's what I'll call the full stack frameworks and what I'll call custom stack frameworks. Now, full stack frameworks are frameworks that kind of take you through everything from your discrete coding patterns all the way through to your user interface implementation. And when I talk about this, I'm talking about something like Dojo, jQuery Mobile, Sencha, because they have specific ways that those applications need to be coded for you, and they have user interface paradigms that are part of that framework. So if you want a certain kind of list, whether you're using jQuery Mobile or you're using Sencha, you basically are building a list using their syntax. If you're doing if you're doing something like, let's say, Sencha, which ends up with HTML and JavaScript applications, because of the way that their API is structured, when you're building your apps, you're basically writing JavaScript. You're not actually coding a lot of HTML. It generates the HTML for you. And because each one of these has their own user interface components, you're going to have common elements in your applications. And they also have their own coding styles. So this can be good or bad. Some people don't like the coding styles of jQuery Mobile or don't like it with Sencha, but if you're working on a team of developers, this can force your team of developers to all follow the same coding practices because they're common, they're documented. There's documentation for all of these APIs. There's pros and cons to that approach for each one of these approaches. When we're talking about a custom stack framework, sorry, I glazed over this column here. I should have said it before I got here. When we're talking about each one of these, I mentioned there's user interface, there's actual architecture, which is the structure of the code and how everything is generated, and then there's your DOM manipulation, which is actually adding or removing elements from your HTML DOM. And these manage all of that for you. When we're talking about a custom stack framework, it's actually broken out into different pieces. So I'll start first with DOM manipulation. Like, you might use a library to do pure DOM manipulation. And when I talk about, or you might not use any at all, it depends on what your approach might be. But when I talk about DOM manipulation, I'm talking about just adding or removing HTML DOM elements, changing attributes of DOM elements, whether it's CSS styles or what other kind of action you might perform, or it's actually walking the HTML DOM structure. Libraries like jQuery or Zepto.js are very often used in PhoneGap applications, mobile web applications. But these are just giving you the ability to modify the DOM. When you're talking about architecture, this is where we get into like Backbone.js or AngularJS, Ember.js, Knockout.js. There's a lot, and I mean a lot of different frameworks. One of the challenging things that I'm sure many of you probably already know is that when you're working with JavaScript frameworks and web applications, there's like a new framework every day. And I wish that was an exaggeration, but I really don't think it is, because it's hard to keep up with them all the time. The conversation earlier, like, do you prefer Backbone or do you prefer AngularJS? I personally use Backbone.js, not simply that I have nothing wrong with AngularJS, but just because I haven't had time to do AngularJS yet, because I've come from lots of different other frameworks. Like, I've done stuff with Sencha before, I've done stuff with jQuery before, I've done stuff with Backbone.js, I've done stuff with total homegrown framework solutions, and there's only so much you can actually keep up with. But, so I don't have anything negative against either one of those. I think the two that I run into most often when I speak with developer audiences that seem to be most popular, and this is total, I'm on the surface saying seeming, this doesn't mean there's actually any kind of actual data to back this up, but I encounter people that use Backbone.js and AngularJS the most. And then there's a third tier where I'm talking about user interface, and this you might be using something like Twitter Bootstrap or Zerg Foundation or Ratchet or Topcoat to actually do UI implementation. And this could be things like containers, lists, button styles, basically all the pieces of the UI that actually make it feel like an application instead of just making it feel like text on a page. You don't have to use a framework. With full stack, You use their paradigm, and it defines all the rules for all of these. When we're talking about custom stack, you pick and choose any of these, whatever you want, or you don't use any at all. It's totally up to you. So before I jump too far ahead, let me switch over and actually look at another application. So this one, I'm going to show you, this is actually a PhoneGap application. I've removed all references to client names because this was actually a prototype that I put together for somebody, so that all identifying information has been removed. But this is actually a PhoneGap application that's been deployed on iOS and Android. And just to kind of give you an idea of what it is, it's a fake banking application. And I've got different kinds of bank accounts. I've got cash. I can drill in. I can see information about each one of those accounts. I can make a payment. I can select whatever data, enter data, let's go to the next step. I can see all of this. This is a PhoneGap application. Every piece of this is just HTML, CSS, and JavaScript. I've already also got some interesting UI paradigms, like we've got the tray that slides out, and let's say I want to see a list of all my different transactions, or I want to see all my payments. Oh, in that case, I need to make a payment, or I want to see my financial advisor. I can get all that information, but you see that the way that this is structured, there's nothing visually saying, hey, this is a web app, or this is written in HTML, CSS, and JavaScript. It's just built with the aspect in mind of it's an application. That's all it is, because its purpose is to provide information for the users. And so we try and design it so that it just fits with whichever mobile paradigm or mobile operating system that you want. In this case, it's styled for iOS. You can have a common UI for your app across all different platforms. You can use, in PhoneGap, starting with PhoneGap 3, you can actually have platform-specific file includes. So if you want a different style sheet for iOS and Android and Windows Phone, you can set up your application structure to do that. But in this case, I just have one, and it's common. It looks like this. And I generally recommend that when you're building applications to create an identity for your application rather than trying to mimic every behavior from the local operating system, because that can get you in kind of this weird uncanny valley effect where people are like, well, it doesn't totally feel native, and people have a negative response to that kind of feeling. So that's why I say, recommend just build something that's a unique identity for your app, your brand, whatever you're trying to convey, and go about that way. Now, I built this using Backbone.js. Backbone.js provides me with discrete coding patterns, so I can, and I can also have separation of my HTML generation from the actual logic for each one of my views. Now, Backbone.js also supports data binding. So data binding is essentially where you have, your code structure, and your views, your HTML structures are created programmatically. And when your data changes, it automatically updates the HTML structures, which then update your view. I'm not taking advantage of data binding in this. I'm manually rendering everything. There are pros and cons to data binding. On one hand, they make it really easy to generate stuff really fast. The con being that sometimes if you want to do things really custom or you want to change behaviors of it, it can get to be a little bit challenging. But it's really up to you which direction you want to go. But let me just go ahead and jump into first the home view. Let me zoom in here so you guys can see a little bit. Basically, this is my home view, which is the home page, encapsulates all the logic for that home view state. I've got in here a class which essentially extends the Backbone.view class, and this is a paradigm that's specific to Backbone.js. And inside of that, this handles basically all the logic for that view. I've got an initialize function, which is going to do whatever bootstrapping it needs when this view is created. In this case, I'm calling render, which actually renders HTML. I've got my events that are defined. These are event maps, so with a specific event on a specific item, it's going to invoke a specific function. So in this case, if I click on Cache Hub, it's going to call the show accounts view. Or it's going to call the show accounts view function. Or if I click on the security HTML DOM element, it's going to call the show security function. And then I have all the functions that are actually behaviors of this view. So I've got my render view, which render actually gets a reference to my templates, which my templates I've already preloaded in another thing, but I'm not going to go into too much detail about this. But basically, I've got each one of my HTML templates. So when I'm talking about the templating, I've got each one of those loaded in a separate HTML file that gets loaded programmatically. I put it into this templates object so that I can reference it at runtime whenever I want. And all I'm doing is generating HTML. I'm sticking it in the HTML element for this object. I'm applying some other behaviors to this, and then I'm returning it. That's my render function. And then I've got my event handlers like show counts view. When that happens, I don't remember what that function does. But anyway, I'm calling this function, and that's going to actually show the accounts view down here. I don't remember. I think that one's to close the door, the drawer if it's already open, and then get down here where it's going to create an accounts view, and it's going to go window.viewNavigator.pushView. The view navigator is an element that I created which handles the transition of content from the right to the left, so it gives you that native feel. Now let's jump over and look what the HTML looks like for home view. It's really, really, really simple HTML. So we've got discrete. So we've got a discrete class which encapsulates all the logic and behavior of that home view. We've got a discrete piece of HTML, so that is the user interface for that particular view, and we've got the coding patterns that allow me to manage all that and define the behavior of how each piece works together. And if you look, I've got a help view, I've got the drawer view, I've got the advisor view, and I have the accounts view that are all organized in the same way. And so that helps me to be able to have code that is, one, maintainable, because it's logically organized, so that you don't have to have code referencing other pieces of code all over the place. And it also, so it's logically organized, and it's also a consistent pattern, so that you can expect that if I open up help view, it's going to look like very close to something like I just showed you. So if I go to help view, we can see, oh, this one's a lot simpler. But for example, in the render function, we're getting a reference to the template. Wow, I'm sure you can't read that back there, but we're getting a reference to the template. We're generating HTML. We're returning it. And then if we actually look at the HTML, it's just going to be the HTML that's used for that one particular help view, if that makes sense.
Is that WebStorm 7?
I haven't done the latest update.
There's a presentation mode available for WebStorm 7.
Oh, is there?
Yeah.
Then I probably need to update to it. See, I'm like one version back. But when I'm showing the help view, that's actually the help view that I'm showing here. So you can see that we have really, really fairly simple HTML to create this view. We've got the behaviors that were defined in that JavaScript file, and then there's CSS styles that determine how this actually gets presented to the user. So that's what I'm talking about when I'm talking about code structure, like a maintainable architecture and discrete separation of model view and of the controller behaviors. One thing I didn't show in here, because this was kind of a demo application, there's not a round trip to a server right now. When I'm talking about my view, I'm talking about data objects. In this case, they're simple JSON objects that are contained in arrays, because the data, while it might change in the application if I change the values, all I'm doing is shoving them back into these arrays, and I'm using these arrays to generate more HTML that's going to be used inside the user interface. But there's still that separation of the actual view, the model, which are these objects, and then the controller, which is all the JavaScript, which controls the behavior of each one of those views. So, we've already done that slide. So let's talk about when you're building these applications, you want to think about the architecture, you want to optimize data transfer. And when I talk about optimizing data transfer, this is not something that's new, and it's not something that's specific to PhoneGap or mobile web applications. It's essentially minimizing network bandwidth so that we have faster throughput and reduced latency of the overall experience. So when I make a request from the server and I want to get data, let's say I have a list and I have 200 items in that list, but I only need 2 pieces of data for each one of those. Do not send me 200 data objects that have 200 properties apiece, because it's a waste of time, it's a waste of space. You don't need to send that much. It's a larger payload that has to be sent from the server. So with a larger payload, you're going to have the additional bandwidth. You're also going to have additional parsing time. So it's overall going to be significantly slower, and I'll say in most circumstances, than just sending simply on demand what we need to render that particular UI. And then you can employ lazy loading, so if you want to take whatever was in your list and then drill into that and have another view that displays all of your data, and let's say then you get all 200 data points for that one specific object. It's in general a better experience to have kind of like an on-demand, only put stuff there once you actually need it. But, and this is the one caveat I'll say, is that rather than, where I said lazy loading is generally good, that is of course unless your server, your backend, for some reason takes forever to parse the data. Sometimes you want to just shut it down to the client so you don't have to keep requesting stuff back and forth, but it's really a case-by-case scenario. But I would say 99% of circumstances, I generally recommend only send the client actually what it actually needs rather than trying to like aggressively push data down to the client. Now let's think about abstract components. When I talk about abstract components, I'm talking about a interface that a programming interface that your application is being developed towards, so that you can easily go back and forth, let's say, between PhoneGap and between the desktop browser. And there's a couple reasons for doing this. One is that you might have an application that you want to live both as a PhoneGap application and living in the desktop browser. The other would be that when you're developing a PhoneGap application, the most productive and rapid development environment that you have for your actual development is the desktop browser. It's far faster to write your code using a code editor, put it into the desktop browser, hit refresh from the desktop browser, see what that code is going to do, and then you also have the debugging tools for the browser so that you can inspect the DOM, you can change the DOM, you can set breakpoints in JavaScript, you can manage execution, you can manage what's in memory. You can do all that inside the desktop browser. You can do some remote debugging on some mobile platforms. You can't do it on all platforms equally, so it's really important to have something that kind of works in the desktop browser. And so if you want to develop something that can work in both PhoneGap and the desktop browser, one strategy for that is what I said, the abstract components, where we have our application, and the abstract component for, in this case, device notifications, would be we have a notification interface. And the application is going to say, okay, notification interface, give me a notification, send me a message, do whatever you're going to do. And in the notification interface, we're going to take a look at it and say, are we in the context of a PhoneGap application or are we in the context of a desktop browser? And if we're in the desktop browser, we're just going to use a JavaScript alert. But if we're in a PhoneGap application, we can delegate to the PhoneGap device.notification API, and that's going to give you a native notification for the platform. And the general part of your application logic is going to be exactly the same. So it's kind of an abstraction layer that allows you to jump back and forth between the desktop and the mobile browser. Now, you don't have to do this when you're developing just any old PhoneGap application, but if you want the ability to jump back and forth between PhoneGap and desktop browser, this kind of a strategy can be very, very helpful. Very similar, let's think of a data storage abstract component. Now for data storage, we have our app. We want to save data, so let's talk to the data interface. And the data interface can save data based upon whatever the context that you're executing this code. So if you're inside of a PhoneGap application, you might be doing, or if Web SQL is supported, you might be doing Web SQL. Or you could be sending it to local storage, you could be saving it just in memory, or you could be doing a request to a service. It's really going to be a case-by-case depending on what your app is trying to do, what's the context, where are you actually running it, but your application logic is going to be up here, and it's just going to say, hey, save this data, let the data interface decide it based upon where you're actually executing the code. And again, so you can jump back and forth between different running environments. Another thing to consider when you're developing PhoneGap applications or mobile web applications is to correctly handle touch. There are two big pieces to this. The first is that you're using HTML in a web view. The default PhoneGap template does this for you, but I've seen many cases where people take this out. These styles, so let me actually zoom in here, prevent the default behavior of WebKit to allow text to be selectable, and disable two parts. There's text to be selectable and also the callout. So when you tap on something and it says, what do you want to do? Cut, copy, or paste this. By adding these CSS styles, you can get rid of that, and so that when you touch something, unless you've actually explicitly made it be selectable, the user can't select text from your user interface. I mean, if you're using a native application, the native applications don't let you actually just select any text and copy it unless it's actually been specifically enabled for you. So if you somehow remove this from your PhoneGap application, you want to put it back in. Like I said, that's in the default template. I see people taking pictures, so I'll wait a second before I move on. Good? Okay. The next thing when we're talking about touch interaction, we want to talk about touch versus click. And there's actually two parts to this. The first thing that you want to think about is, are you using a click event or are you using a touch event? Because there's a distinct difference inside of most mobile devices in the HTML rendering layer, or the web views of most mobile devices. And there's a caveat to this, which is a recent development with different mobile operating systems. But when you're using click events, if you haven't done specific things to make those click events immediate, the operating system introduces up to around a 300 millisecond delay before it actually acts upon that click event. I see people who look like they've run into that in the past. So if you think about it, that means you touch something, it's actually 300 milliseconds before your app responds in any way. This can be really deceiving. People will think that your app is slow because it's immediately not doing something as soon as you click on something. Whereas if you use touch events, you don't run into this. So with a touch event, as soon as you touch the interface of your app, it responds to that. And just as an example, I've faked it inside this. I'm using a timer so you can see the difference between immediate and then and 300 millisecond delay. But well, I'll just show you and then I'll talk about it. So if I click this button, you can see the touch speed first happens immediately. And then after a 300 millisecond delay, we're showing click speed. I'll do that again because it's pretty fast. It's a small delay, but if you add that up to every single interaction in your application user interface, that adds up and people get really, really, really frustrated. If you're operating inside of a mobile web browser, people might expect it a little bit more, but if you're deploying an application, it's a natively installed application, people expect it to be immediate. There are libraries that you can use, like FastClick. There's a couple of, did I list any others? No, I didn't list any other ones. But FastClick is one of them. Zepto.js has a tap interface, which abstracts some of this for you so you don't have to manage it. But basically, these leverage touch events so that you can have immediate response to your user input. Now, the second part of touch versus click, and it's not just touch versus click, but it's managing input, user input, is that you want to always immediately have some kind of visual feedback to your users. If you tap on a button and you don't provide any visual feedback, let's say you tap on a button, you make a request to a server, get data, but you're not actually either changing the button state or changing the view or giving some kind of loading indicator, people are like, hey, nothing happened, let me tap it again. Hey, nothing happened, let me tap it again. Hey, nothing happened, let me tap it again. They think it's slow, and then you're making like 10 requests to a server when you really only needed one. So, like I said, make it immediate in actual response, and then provide immediate user feedback so that they know something is happening, as opposed to just sitting there and waiting and be like, oh no, it works, but the user doesn't know it's actually working. And when I talk about design for the user, you have to think about what are they experiencing and how does that impact their overall perception of the entire application. I see pictures being taken again. I will drink beer. This is fantastic. Okay, the next thing I want to talk about is using hardware acceleration. Now, let me jump back over to this app. The transitions that I have right here are, even though I'm running in the iOS simulator, they're just as smooth on an actual device. And that's because it's leveraging the GPU for the rendering of each HTML DOM element. And that GPU rendering can be achieved simply by using a couple specific CSS styles. The first one is when you have a page, if you want it to be composited by the GPU on the device, all they have to do is add the translate 3D transformed in CSS with a 0, 0, 0 transformation. This means it's not actually going to transform it in three-dimensional space in any way. It's just going to force the GPU to render it. If you want to have the element, shift 100% to the left, you can use Translate 3D and go negative 100%. And that's going to shift it 100% totally to the left. If you want to have it be an animated transition, so this is actually telling it where to put it. If you want to have it animated, you can just use a transition. So and you set the transition duration to like 0.25. Actually, that should be 0.25 seconds, not 2.25 milliseconds. But that would be really, really fast. But basically, by leveraging CSS transform and CSS transition duration, you can have a hardware accelerated, well, just using this alone, it's hardware accelerated composition, so it's actually being rendered and composited on the GPU. And using the CSS transition, it's actually doing the animation from one place to another. Now, this works if you're using Translate 3D. If you have Translate 3D set 000, but let's say you're also setting CSS top and CSS left, and let's say over an interval you're trying to animate CSS top and CSS left, it's not going to be hardware accelerated in the animation. Because when you animate things, you only want to animate properties that are actually hardware accelerated. CSS absolute positioning with top, bottom, left, right are not hardware accelerated, but you can do the same kind of animation using the Translate 3D. So even if it's like on a JavaScript interval, if you do Translate 3D and in the X position you go 1, and the next interval you go 2, 3, all the way up to 100, it's going to animate to 100, and it's going to be hardware accelerated with that composition. But if you did that with, like I said, animating the CSS left property, left is not hardware accelerated. Excuse me, it's not a hardware accelerated transition, and it's slow for well, a couple reasons. One, because left doesn't force it on the GPU, but also anytime you make a change to an HTML DOM element that affects the size of the HTML DOM element, where Translate 3D does not affect the size, it forces the browser to use redraw algorithms to calculate what is the size of this, how does it impact any content within it, how does it impact the content around it. So anytime that, like I said, it changes the actual size, which CSS, top, bottom, left, right, width, and height all impact the size, it forces those computationally expensive browser reflow operations. So you want to minimize how many times you're actually forcing your content to be resized. That was a mouthful, I feel like. And oh, the other thing I want to talk about with hardware acceleration is use it responsibly. Let's say I have my DOM tree, and I have a root element, and I have 20 elements inside that, and each one of those I have 20 elements inside that. You don't want all of those to use Transform 3D, because in order to render the top layer, every one of those child nodes has to be rendered on the GPU. So it has to be uploaded to the GPU, then it can be composited, then one layer down, those have to be on the GPU, they can be composited, then the top layer can be composited. If you want all that content to be just animated, especially if you're doing like a left to right transition, only put the top level on the GPU. The other thing that you need to be careful of, and there's some web frameworks that are very guilty of this. If you're trying to animate content in flickers on some devices, if the dimensions of your DOM elements exceed the maximum texture size for the GPU for the device, it's going to flicker when it gets loaded and unloaded from the GPU. And on a lot of devices, that maximum texture size is in pixel dimensions. I think it's 1024 by 1024, but I know on iOS devices, especially newer ones, it's like 4096, I think, by 4096 or something, which is a pretty big pixel dimension. But if you exceed that dimension, then you're going to have content flicker when you're trying to animate it. I could go on for way too long on that, but it can be kind of a difficult thing to debug. Lastly, actually I don't know if this, yeah, I'm close to the end. Lastly, one of the things I want to talk about is that you want to optimize your applications for performance. And this is not something specific to PhoneGap. It's not something that's specific to JavaScript in general, but you want to make sure you're writing efficient code. What's your order of operations? Like if you're changing sizes, if you're doing things that are forcing layout redraw, those things are going to impact the overall experience of the application because it's additional computing power needed to complete whatever operation you're trying to perform. An example. In this we have some really basic code. We have some really basic code. This code is going to be slow to execute. And what's happening is it's using jQuery syntax to get an object. So it's going to be a header and then the links with a class of back. And for that, it's going to add an event handler of click, and it's going to add this event handler. In the next section, it's going to take that same object and it's going to apply CSS. We're going to apply more CSS, and then we're going to set an href attribute. Now, can anyone tell me what's wrong with this code?
You're not caching your variables.
Yeah, it's not caching any objects. So let me jump back up here. Every time it's executing this piece of code, it has to walk the HTML DOM and find the HTML element in order to perform this operation on that element. So that's additional computing that we don't need. And so if we jump to another one, the fast implementation, all that we've done is create a variable called back button. Then we get a reference to it, and then we're performing these functions, each operation, on the back button variable instance. It's a really, really simple change. It does not add complexity to your code, but it does have if you have a very large code base, this can have a very significant impact on the JavaScript execution and the performance of your application. I will be sharing the slides too, so for everyone taking pictures. I forgot I should have mentioned that earlier. Take pictures, take pictures. Oh yeah, by the way, here's the URL. Here's another one. Can anyone tell me what might be slow with this? Mm-hmm. Yeah, for each one of these images, it's an additional request. In this case, if it's on a server, it's an additional request to the server. If it's on the local file system, it's an additional request to the local file system. But that might not seem like much, but again, if you are talking about the time that it takes to load things into memory so that it can be visible to the user and respond faster, each one of these requests actually adds latency to the overall experience. If we I'll just zoom in here. If we look at this is a sprite sheet. All of these little icons are in one image, so it's one request to the server or one request to the local file system. And then you can use CSS styles to basically just show a little portion of that for whichever object you want these to be applied to. So again, instead of loading 5 different images, just load one. And then put everything inside that one, and it actually is, so there's less requests to wherever that file is being hosted, and also there's less number of objects that are actually in memory. You just have one object. When the CSS styles is loaded, it's loaded that one time, it's cached in memory. And then for every CSS class which leverages one of these, it's referencing that same image that's in memory. All right. Here's another one. What would you change for this to make it faster? We need Jeopardy music. Perfect. Okay, so for this one, there's actually not something functionally wrong with this code. However, it's the impact that it has on the user. So yeah, we're making an AJAX request to a service, we're getting data, we're displaying that data when it comes back. But if this was triggered, let's say, on user input, you tap a button, makes a request to the server, you're getting this. That user is waiting for that request to be fulfilled before it actually displays anything to the user. If that request to the server times out, or it's really slow, you're on a slow network, I mean, it could be 30 seconds before you get any feedback back to the user. The fast implementation of this is very, very similar. And it's not that difficult to do. Is that before we actually make a request to the server, display your view, display something to the user. It can be a little loading animation, or it's got to be some kind of indicator that an operation has taken place, so that it's visual feedback, so the user knows, hey, it's doing its job, it's working, don't keep tapping on it. And then once that request to the server is complete, then we update the view. Okay, here's another one. What's wrong with this code?
Don't use jQuery.
Hey, I actually like jQuery. I don't think it's the framework itself, but I'd say jQuery is not the problem here.
You're creating DOM nodes in jQuery.
References to the list.
You're right.
Oh, okay, I'm sorry. Yes.
So yeah, it's appending. The first thing it does is it appends a list to the body element. You know, there's nothing wrong with that. We're appending it. But then we're looping over data. It's 100 data points, and for each one of those, we're appending a list item to that list. Now, when this happens, you're appending list items to an event or an element that is already on the DOM tree. So for every one of these, it causes a reflow operation because the HTML structure has changed. That means it has to be remeasured. How does it impact any content within that? Within each one of those, how does it affect the content that's outside of that list? This can be significantly faster when you're actually invoking the code by, well, there's two things that you can do. Either one, you create the list and you loop over and you append all the items to the list and append into the body as the last thing you do, or you create just a blank HTML string, and then when you're actually appending it, you're only creating your DOM elements with that one simple flat string request. It's up to you which approach you want to go, but the biggest thing that you want to do is make the browser do as little work as possible when you're actually executing your JavaScript. When you're doing something like this, you're concatenating the string, and earlier I said templates are much better and cleaner than concatenating the string. I'm just really trying to demonstrate the concept here. But you want to minimize the actual impact on neighboring DOM elements and reflow operations of the browser. That's the big thing, is to avoid reflow at all costs because it's expensive. If you've ever encountered an HTML application that when you're interacting with it, let's say you're putting new content on there, the whole UI locks. Like, even if it's a fraction of a second, the whole UI locks. That's probably because of browser reflow operations. It's because you've changed the width, you've changed the height, you've changed something with your content, and so the browser has to calculate what's the impact on all the surrounding content, and does that have to be re-rendered? And if that's inside of that list, we just caused 100 browser reflow operations, where with this approach, we're only having one reflow operation.
But when the user sees it happen?
Sorry, who said that?
Right here.
Okay.
But on the first way, when the user actually see that happening, and
well, if you're just looping over 100 items in a list, actually no, because it's going to it's going to happen in the same execution cycle. So it's going to, basically the UI thread is going to be locked until all those DOM elements have been created. If you are only creating it one time though, then there's only one reflow operation, so that the overall, like having a locked UI is not going to happen.
okay.
Basically, any DOM manipulation in a for loop is bad.
Yes.
Yeah.
Unless you remove, so let's say if you're appending, remove the top element that you're appending to from the DOM tree, then you can append in a for operation, and then add it back to the DOM when you're done. And that way it only incurs one reflow operation.
Document fragment, I think, comes into play. Kind of manipulating and placing. What you just said reminds me of document fragment, because you're actually working with the DOM element and then placing it back into the DOM.
Yeah, exactly. That's right. So you're working with it and you're placing it back. Like, it's not the DOM access that's the slow part. It's actually the reflow operation.
The browser reflow.
If it's on the DOM tree,
Yeah.
that's the slow part.
Are you going to show how to measure that, like visually, like in DevTools? You have an example?
I don't necessarily have an example.
Let's see some on-the-fly coding. I'm going to put you on the spot.
I'm not going to necessarily code it on the fly right now, but I will show
Just
you.
Just paste that into the browser, or into the console.
In the timeline here, so in DevTools, is anyone not familiar with Chrome DevTools? Good. I'd say the developer tools, all major browsers have good developer tools. Chrome's DevTools, in my experience, have been the best for the way that I operate. So I really, really like them. I mean, you can view your actual HTML structures. You can see all the resources that are used by your application. You can see all network requests, which in this presentation I have none. You can see all the source code that's for whatever is in memory in the browser. But you also have the timeline and you have profiling. So the timeline, you can see the execution of events, and so like when events are triggered. You can see the frames, which I'm not actually profiling this right now, so you're not going to see it. Well, let's try it. I don't know.
Profile the transition of reveal JS.
Yeah, let's do that. I thought I hit start.
Yeah, hit record.
Yeah.
There it goes. There it is. 60 frames per second.
Do a bunch of stuff. Okay, that's probably good enough. So what happened when I just did that is I hit start and it started recording.
All your CSS transitions
Yeah.
that you just talked about.
I was going to see if I can resize this, but it doesn't look like it lets me resize it here. But basically, you can see. Actually, it looks like it's going really slow all of a sudden. Okay. A little bit hard to see here, but let me zoom into this so you can see it. What it's giving you at the top is a graph of the amount of time it takes to render each frame, so browser redraw cycle. In each one of those, you can see the colored bars. Each of the colored bars represents a different action. So it might be a timer event. It might be the green ones are paint cycles. The purple ones are recalculate style. Recalculate style and recalculate style and layout, those are reflow operations. You want to minimize those absolutely as much as possible. And so if you're using DevTools, you're using the timeline, you're profiling, you can start the recording of behavior and then just interact with your app, walk through a bunch of different scenarios, and then once you stop, you can go in and you can actually analyze what operations was the browser doing, how long did reflow take, where am I actually introducing a reflow, what's causing additional like paint cycles in the browser, and it can be, you get really in-depth into the actual inner workings of the web view at this point in time, but it allows you to extremely optimize your code so that you have the absolute minimal impact to the actual execution and essentially 60 frames per second target that you're trying to hit for the interactions of your application. So that's really, really handy.
It lets you measure the slide you just showed with the for loop, right?
Yes.
I mean, you were talking about reflow, and that's, I guess, what I was.
Yeah.
That's how you would measure it.
Yeah, that's how you would measure it. So when you do the loop and you're adding elements to the DOM, 100 times, you're going to see like 100 different layout or recalculate style calls, which you're going to notice that impact in the browser. And so I'm talking about using the browser to do this. On iOS, you can do remote debugging. Hopefully on Android, you'll be able to do it soon because Android 4.4 now has a new web view, which is based on Chrome, which is going to give us, one, a faster rendering environment, a significantly better performance, and that'll give us the ability to have remote debugging. So you can actually do these from the desktop on something that's actually running on the device. But again, I digress. I'm talking about this. It's like we're talking about testing on a desktop here. And we don't see any problem in execution on the desktop where we can analyze what parts of it might be slow. On a mobile device, you're talking about a device that has a much slower GPU, a much slower processor, less memory, and overall, it's a slower device than a desktop computer. So while you might not see problems here, when you get onto your mobile device, you might see significant ones that you didn't think you were going to have. You can use techniques like this to figure out where are those slowdowns actually coming from. So test on the desktop, also test. The most important thing is to test on mobile devices. Cannot emphasize that enough. Also in DevTools here, you can do profiling. So with this, I'm not going to run this one, but you can do a CPU profiling, so how much time is being spent on each operation on the CPU, what's in the memory heap, and then you can compare different snapshots of memory. So you can see, do I have a memory leak? What's the memory? What's the type of object that's being leaked? What's loitering? What's hanging out? And from that, you can start to track down where are these objects in memory actually coming from. That's another talk in itself. And of course, there's console. Everybody loves the console, where you can see anything from a console.log statement. But anyway, back to my summary. To make applications with PhoneGap or for the mobile web that are performant and behave as close to native as possible, strongly recommend doing single-page architecture. Use HTML templating to have an abstraction between your data and the UI that's being generated, and it also lends itself to cleaner code. Have structure to your code so that you're actually following consistent coding patterns, and that way, let's say you take a break from your application and you come back to it 6 months to a year later and you need to make changes. If you're using consistent coding patterns, they look really bad from up here. So, like I said, single-page architecture, use templates, structure your code, optimize data transfer. Don't send data across a wire if you don't need to. It introduces latency. Don't make people wait if you don't have to make people wait. Abstract components if you want to be able to jump back and forth between desktop browser and a PhoneGap application. Optimize for touch. So that's the 3 things that I mentioned. 1 is touch versus click events. 2, making sure that you override the default behavior of the browser so the text isn't selectable or doesn't feel like a web page. And 3 is that you're providing immediate feedback to user input. Next, use hardware acceleration when possible, though I say use it responsibly. And when you're doing things, make sure the action that you're performing is actually hardware accelerated and not something that's going to introduce reflow and cause it to, any benefit you might have from being composite on the GPU, you would lose. And also, optimize your code for performance. A big part of it is just efficient code and best practices when you're actually writing your code so that you're not unknowingly introducing things that might be problematic down the road. And with that, I'm going to say thank you. I won't take all of your night. My name's Andy Trice. Like I said, I'm an evangelist for Adobe. You can contact me anytime. I'm atrice@adobe.com. My blog is tricedesigns.com. On Twitter, I'm Andy Trice, and I have a bunch of open source and PhoneGap examples, github.com/tricean. I will be, actually this presentation is actually already online, but I'll be reposting it again, and I'll send out a tweet with a link to where all that's located. And we've recorded it, so once it's available, we're going to put the video of this up here too, so if you want to look at something again later, you want to share it with your colleagues, strongly encourage that. Well, thank you.
Awesome.
And I'm drinking beer throughout the entire presentation.
Awesome. That's how we do it in the ATL, isn't that right? All right. Next we got Luke Warren coming up to give us a lightning talk on cores. Not the beer cores. Cross origin resource requests. Which is something. What's that? Oh yeah. So you got a little louder there?
Yeah, good to see you.
Good talk.
You leave? This is supposed to be real quick. The file protection.
Okay. 1, 2, 1, 2. Check. Testing. So good. Yeah, go ahead and get set up. See if I can find the IT guy.
Oh, there's a PGA.
That's
Or maybe it needs to be right up there. I don't know.
Yeah. Hey everybody, by the way, if you just got here from the traffic, we're going out for drinks at, what's the name of the place, Rick?
Yard House.
Yard House, sponsored by Blue Fletch. So after this talk, we're going to walk over there and grab a few drinks if you guys want to come and mingle. You guys talk about it? Check.
Yeah, definitely. Or
I was trying to do that. So I was doing a lot of those therapies where I would just through practice, I would take the variable and name it something, and assign it somewhere down deep and say, call variable. Instead of actually plugging in that variable every time. I get
this. Maybe. How's this? Okay, can you guys hear me okay? We're going to make this real short and sweet. Like it's supposed to be. So, how many of you guys have ever used, this is HTML5 meetup, so probably most of you have done this. Majority of you, I assume, are familiar with Ajax. Who here has not used the XML HTTP request object? Have you not used it? Everybody's used it. Fantastic. We're going to skip right past all this. So, have any of you ever ran into cross-origin resource sharing problems? Yeah, okay. Where you load, so essentially this is what it is. Your client will load a web page and some JavaScript from one server. And then in that JavaScript, maybe there's a request to another server to get some kind of resources, either XML or JSON or image or something. And the browser will essentially see that you've made a request from a remote web server, and it'll stop it. It'll stop the request, just stop it in its tracks. As soon as the headers come back, it'll just go, whoa, I'm not dealing with this. So what's going on is, let's see if I've got the headers in here. All right. So when your web browser makes a request, it provides all these request headers. And one of the things it will send is its refer. It'll say, hey, I came from this server. And the remote server may be interested, it may not. If the remote server returns something like this, then your web browser is going to stop the request. What you need the web server to return is this line right here. Something similar to this, with something here on the end to say where it's cool to if you got your code from. So the web browser will, after the request comes back, the web browser will look at the refer, which I guess it already knew, and then it'll look at the access control allow header. And if these two things don't match, it'll just cut the request off, right? So I've got a little example here. It's going to be real fast. So I wrote a little servlet, blah, blah, blah. And in my little servlet here, I've got this header that I could add to the request, but I have it kind of blocked out. I've got it commented out. So I loaded this page from localhost, and when I query my little servlet, it responds back to me just like I want it to. It gives me everything I needed. And here are the headers that it got. So it sent its little request headers. It sent that refer. And this is what it got back. Okay. Everything was kosher because the reason the request worked was because the place it loaded from, the protocol, the host name, and the port were all exactly the same as where it requested this new data from. What if that had changed? What if I instead wanted to request some data from a different location? Same thing. Boom. Make the query now. Okay, let me show you. So you see now I got some funky stuff back. Here's what happened. You see the request headers here, but you don't see any response headers. I guarantee you the web server sent a response back because they didn't care. They just said, here's your data back. But the web browser saw that there was not an accept, allow, blah, blah, blah header in the response. So the web browser implemented its CORS-based security and stopped the request. The reason for this is like to stop something called cross-browser script injection or something. I don't really understand it too well. I've never really understood why it would be a problem. But it is something you have to deal with. So here's what you have to do. You have to go talk to the person you want to request the data from that owns the server and ask them to please provide this response header. Something like this. They can put some intelligence in it if they want to look at your refer header and then make some decisions about whether or not they want to serve the data out. But as long as they return a star or something that matches the refer, so now I'm going to, I'll show you what will happen. Okay. I'm going to make the exact same request again. Notice that localhost doesn't match the IP. That's actually IP of this PC here. You query it again. Boom. This time it worked. I was going to go through an example. The reason it worked this time is because the server returned this happy little header right here. Okay. So, two more things I want to share with you. You got to go talk to your sysadmin or whoever owns the web server and get them to add this header for you if you want to request data remotely. Second of all, if you're just doing development and you just want to try to make something work, you realize that the server team's 3 months away from giving you that header. But you need to do your development and make sure it works. Here's what you do. If you can run Chrome in this mode right here, you pass in this flag when you start Chrome, disable web security. Chrome won't care if you're doing cross. It's not too happy when you do this. It gets a little unstable. But now let me go turn my header back off. Okay, now the header's gone. Now we're going to make the request with disable web security turned on. And I didn't get the accept header, the accept whatever content header, but the request still completed. this proves that it is in the browser to stop your request. That's pretty much the end of my talk. But there's one more thing I want to tell you, and that has to do with PhoneGap. PhoneGap is like the honey badger. It don't care. All right? It'll go out and query all day long, whether or not it's cross-origin or whatever. So this code, this little PhoneGap app, I launched from the little local simulator here, and I'm printing out the headers I'm sending from this little PhoneGap app, and it actually gives you, I think it sends the referrer down or something. Maybe it doesn't. It doesn't even bother to send a referrer down. You know why? Because PhoneGap don't care. So you can load your app from one place and request data from wherever server you want PhoneGap, and you can and request it completely.
As long as you whitelist it.
Oh, you have to whitelist it?
Whitelist the domain.
I didn't whitelist it. Simulator. Okay. Is there anything else anyone else would like to know about this? Yes?
Could you use a proxy service that you control?
But the thing is, the proxy service would still have to have the same protocol, host name, and port. Those three things have got to match, or the web browser, if it doesn't see that accept header, will block the request when it comes back. Okay, that's it. Thanks, guys.